Hello everybody. In this movie I'd like to show how microscopy image browser can be used together with Imaris. So Imaris is a commercial software package which is available from Bitplane, and it can be used for many things, and in the simplest case you can use it for visualization of models created with microscopy image browser. Depending on the installation you may have ImarisXT. It's an additional module which offers the possibility of direct data exchange between Imaris and external programs. So if you have this module, then the data can be directly exported from MATLAB to Imaris. However, if it is not available, then the data and models have to be saved to a disk in TIFF format and opened in Imaris. So I'll have two videos, and in this first one I will show you how the data can be, how the models can be exported from MATLAB, from microscopic image browser. And in the second video I will show you how the same could be achieved using ImarisXT. So let's get started. So I will first open a data set and we'll open the model. So this is a model which has the lipid droplets in red and nuclear envelope in the blue and the plasmic reticulum in yellow and mitochondria. So this model was segmented in one of the tutorials available on YouTube, but in this particular video I would like to visualize this model in Imaris. So in the simplest case, what I have to do, I just need to go to models and save model as, and select here the TIFF format. So by default it adds up MIB as labels before the file name, and I just save it. And there is an option to save it as 3D TIFF or a sequence of 2D files. Both ways are fine, but if probably it's easier just to have it in a single file, so I select 3D TIFF. So now the model is saved. The only thing is to take care is the voxel size in Z dimension. The voxel size in X and Y will be automatically obtained from the file by Imaris, but the Z is going to be missing, so we have to remember this number. So now I switch to Imaris and I'm going to open this dataset that I just saved. It is labels HU7, this model. So when I open it, you can see that it's shown in red. First thing which we should do is just make sure that the voxels are correct. So we go in Edit, Image Properties, and here we just set the Z pixel size in Z plane as 30 nanometers. So now the dataset's properly stretched, and then we can try to generate a model, a surface. So first surface that we're gonna do is gonna be the, for example, lipid droplets. So I clicked surface, then I go through these steps in this dialog. So when we have all our models are within a single file, and in order to generate them we have to uncheck this smooth checkbox to make the model correct. So when it's unchecked, now we can see that all data is they have the intensity of the data sets are ranging from 0 to 4, where 1 is lipid droplets, 2 is nuclear envelope, 3 is in the plasmic reticulum, and 4 is mitochondria. So to select the lipid droplet, I have to make sure that both of these buttons are green, and just select with the mouse this peak and press finish. So now I can see that I have these lipid droplets segmented. Now I create a new model and again go through this dialog steps, uncheck smooth, and then select the second peak, and these would be this should be a nuclear envelope. So it is there. Then we go to the next surface. Again, uncheck smooth. Next, and select the third peak, which is endoplasmic reticulum. Press finish. Right, and then the last one, the last model is for mitochondria. So just select the fourth peak. Alright, so now we have all the models segmented. Now we just need to make sure that the colors are correct. So we select the surface 1, click on this color tab, and select any color we like. So these are lipid droplets, they were kind of red color, so I just select it here. I click on the second one. This is nuclear envelope, it was in the bluish color. Then the third one, ER, it was in yellow. So kind of something like that. And then the last one, mitochondria, they were green. So we have all the organelles shown, and what we can do in the file step, we can open an actual volume. So I select open. I don't want to send any save any changes, and I select the volume which I have in TIFF file. If it is not available, then it can be just generated from here by file, save image as, and select here TIFF format. So I just can overwrite this file. Okay, so then I open this file, and now I have the volume. Let's see how it looks. So now we have the same problem that the pixel size in Z dimension was not obtained, and we have to set it manually in the edit image properties. I'll set it to 0.03. Okay, so the volume is correctly stretched, and since it was the grayscale image, so we need to change the color. So I click on this channel and click in the center, press OK, and in the visualization settings I need to change it to minimal intensity projection. So now I have the volume and my segmented models together, open in Imaris, and I can do all kinds of visualization I need. For example, it's possible to make animation or do some snapshots. You can turn on the ortho slice module to see some of the dataset together with the volume. And in this case, again, it can be used to make any kind of required visualization. So this is one of the ways, one way to use Imaris together with microscopy image browser to visualize results of the segmentation process. But opening these files, it's a little bit tedious, and it's better to do using ImarisXT if it is available. And I will show you this in the next video. Thank you.